rocks undergo little change in appearance. Slate is a metamorphic rock that started out as shale, a rock that looks nearly identical to slate. Just as magma finds its way up through the cracks in the Earth's crust, water finds its way down. Much of the water that falls on land soaks into the ground or finds its way down through cracks in rock. Rocks can actually absorb water, just as a sponge can absorb water. And this next demonstration will show you how. 300 milliliters of water have been added to a beaker. Next, a sandstone rock is placed in the beaker. After several hours, the rock is removed. The amount of water remaining, less than 250 milliliters. More than 50 milliliters are gone. The missing water is in the rock. In some places, underground chambers exist in the Earth's crust. Sometimes these chambers occur near magma chambers. When water finds its way into the crust, it will fill the chambers. The water becomes heated by the magma and boils. Pressures build, and the expanding steam causes an eruption. This is similar to what happens when a kettle boils. But in nature, the results are a bit more dramatic. The place where water erupts from the ground is called a geyser. This one in Yellowstone Park is named Old Faithful because, like clockwork, it erupts once every hour. An hour is how long it takes for groundwater to fill the empty chambers, boil, and erupt again. Much of Yellowstone Park is situated directly above a magma chamber, and that's why this area is known for its many geysers and hot springs. Hot springs don't erupt. They just simmer and boil. They've been boiling like this for thousands of years and may continue to boil for thousands more. Each time Old Faithful erupts, it releases a great deal of energy that could be put to work. That's why in some places where you find geysers and hot springs, you'll find geothermal plants. These plants use the steam produced by hot springs and geysers to drive other machines, which in turn produce electricity for our homes. People have been using the things they find in the earth to make energy for a long time. One such energy source is oil. To understand how oil finds its way into the earth, we first have to learn about another type of rock. In some places, the earth's crust is exposed in layers like the layers of a cake, but this cake is millions of years old. The layers were formed when this part of the earth was underwater, and one muddy layer was deposited above another layer. Over thousands of years, the layers were pressed down by the new layers above them and turned into rock, sedimentary rock. You can make your own sedimentary rock simply by mixing water with some stones, sand, and clay. At the end of the day, you'll discover that the water has evaporated, and what is left behind are hardened layers of sedimentary material. When you look at layers of sedimentary rock, the newest or youngest rock is near the top. The oldest is at the bottom. Old layers of sedimentary rock may also contain the remains of ancient plants and animals that lived in oceans and lakes millions of years ago. Over time, and under the heat and pressure found in the crust, the remains can turn into a rock we call coal, or into a slippery substance we call oil. Both oil and coal are used as fuels. When they burn, they give off a lot of heat. Oil, as well as another fuel, natural gas, exists underground in the cracks and crevices of the earth and within rock itself. Some rocks are saturated with oil. When people drill for oil, they may have to drill thousands of meters before they can tap into rock that is filled with oil. Then the oil shoots to the surface. Oil and gas are usually found in sandstone. We've already seen how sandstone absorbs water. Well, it absorbs oil nearly as easily. Sometimes oil can be found in shale, another common sedimentary rock. But shale is very hard, and the oil is very difficult to get out. In some places, the Earth's crust has been gouged out so that the miners can reach important mineral resources like gold, silver, and copper. This mine in Utah is the largest open pit mine in the world, the largest hole ever dug. It's 3 kilometers across and over 800 meters deep. Our cities are built of materials we've taken from the earth. Iron, stone, and glass, which is made from silica, come from the Earth's crust. In this program, we've seen how scientists use shock waves to learn more about the Earth's interior. We've seen how the Earth's interior consists of several different layers, and that the Earth's outer shell is broken into more than a dozen plates which move in a variety of directions, carrying continents and ocean basins with them. We've seen how the Earth's crust is filled with cracks, some of them called faults, and that when a fault slips, it releases energy in the form of seismic waves, causing earthquakes on the Earth's surface. We've seen how one side of a fault can rise up on end and become fault block mountains. Folded mountains are formed when the Earth's crust is squeezed together, creating folds. We've seen that magma can rise up through the Earth's crust, erupting as volcanoes. Or it can remain just beneath the surface in large chambers. Magma and lava that harden turn into a variety of rocks, known as igneous rocks. Igneous rock formed underground can reach the surface, either by uplifting or when softer rock above it wears away. Many mountains contain igneous rock that has risen to the surface. Metamorphic rocks are rocks that have become changed under the heat and pressure found in the Earth's crust. We've seen how water enters the ground by soaking through soil and rock, and by following cracks in the crust. Geysers and hot springs occur in areas where you find groundwater and magma chambers. The steam created by geysers and hot springs can be harnessed to produce electricity. We've seen that a third type of rock is called sedimentary rock, and within some layers you can find coal, oil, and natural gas. Finally, we've seen how the Earth's crust has been mined for valuable minerals and building materials. We've taken so much from the Earth's crust that when you ask the question, what's inside the Earth, you need only look around.